So, event specialism is how the different athletes are. It's the training and the differences that each athlete has. So, for Usain Bolt and for Amber Annings, they've both been trained in sprinting, mainly for Usain, the 100 meters, um, but also does the 200-meter events. So, they are specialized to that event compared to me. I play tennis, so I have a different skill set and I'm less trained in the 200 meters than them. And this can show in the data in this graph. I can't hold my my max velocity, but for as long as Usain Bolt can, and Amber Annings can't, but then she can do the large sprint for harder at the end. So that gives her the advantage over someone like me. Usain Bolt and Amber Annings were also running on a track with their own blocks, whereas I was running in a sports hall and I didn't have blocks to use. So in that instance, they will then have the advantage over me, who's a tennis player who doesn't have the skills, as good as skills to be able to run that distance that fast because the court is smaller, so I'm more turned to shorter distances at a high pace. So the overall event shows, we'll start with me, that I accelerated fast up to my max velocity up at the 100-meter mark is pretty much where I got to my max velocity, and then I slowly went down a little bit in a decrease in speed right to the end. But then Amber Annings, she did the same sort of increase as me. Well, all three of us did the same sort of increase where we went up to a very high acceleration and then up again to our max velocity, the 100-meter mark, and then Amber Annings went down at a steeper gradient, showing that she decelerated more, but then she then, for the last 50 meters, accelerated and went much faster. But then Usain Bolt managed to keep his velocity a little bit. He was decreasing in acceleration, but he managed to keep his velocity a bit better than I did. So he managed to then get much faster. And then, as shown, I was running the slowest as my line is the lowest down, and then it was Amber Annings, and then Usain Bolt at the top was the quickest, and he got there in the least amount of time. So the overall speed for Usain Bolt was 10.05 meters per second. That was his average speed across the whole event. And then Amber Annings, her average speed using the equation speed equals distance over time was 8.26 meters per second. And then my average speed was 6.6 meters per second over the whole event. And then the velocity was the same. Problems with data like this is that looking at the overall event is that it's an overall average of the whole event. It doesn't take into account the start where you're trying to get up to that speed or when you're trying to maintain that speed through the middle sections of the race, or if you come around the corner, then you might have a decrease in speed. It doesn't show you any of that data if you're just using the average to try and improve. You want to improve certain parts of your race to then get better overall. So looking at the first section of the race, which is in the blocks. So as we know, there is an interrelationship between mass and inertia, where the inertial value equals your mass. So at the start, on the blocks, Usain Bolt's inertial value is 95 kg, because that's his mass. Amber Annings is 61 kg, and then I'm 65 kg. So therefore meaning that the force required to move each athlete out of the blocks varies. So Usain Bolt would need the largest force pushing back towards the blocks to then get his body to move, because 95 kg, it's a lot of weight, but then he's a big guy, so he can and has lots of muscle, so then he has the ability to do that. And then, but it does take a lot of force. And then Amber Annings is the lightest, 61 kg, so it'll take the least amount of force to get her moving out the blocks out of the three. And then I'm in the middle at 65 kg, where it will take me a little bit more force to to push myself out of the blocks to then get moving. And then this mass inertia links to momentum, shown at the bottom right-hand graph. And coming out of the blocks, it shows that Usain Bolt has by far the largest momentum, because he has the largest amount of. He's running the fastest, but also has the biggest mass, therefore meaning his momentum would be the largest. And then it is much closer between myself and Amber Annings, as I weigh a little bit more than her. So it would, but then I'm running less quickly. But then she weighs less, but she's running more quickly. So it means that the momentums are a little bit closer, but she's just got more momentum than I do. And then moving on to the first kind of 0 to 50 meters in the race. So for the first 0 to 50 meters on each of the graphs, we're looking between the distance 1 to 2, which is the first interval. So for the velocity, it shows that all three athletes, their velocity just goes from 0 straight up in acceleration, as we're all moving from stationary going up to our peak velocities, which for everyone happens in the second interval. But all three of them are the lines moving up as shown, and Usain Bolt's is the steepest and the highest, as he's going the quickest, and then it's Amber Annings, then it's me. In that first 50 meters, Usain Bolt reached a velocity of 8.93 meters per second. Amber Annings reached a velocity of 6.83 meters per second, and I reached a velocity of 5.56 meters per second. And then, as shown in the middle graph, the acceleration. Again, in that first 1 to 2, everyone gets to their highest acceleration, going from 0 to 50 meters, because it's moving from stationary up to actually running, so it will always be the highest acceleration. Usain Bolt is accelerating the most. He goes up to 1.6 meters per second, which is his highest, and then it's Amber Annings goes up to 0.93, and then I go up to 0.6 meters per second in that first, up to that first 50 meters where I'm accelerating. Everyone's accelerating up from stationary. And then for momentum, no one in the first 50 meters reached their highest momentum, as they hadn't got enough velocity to be able to do that yet, because they haven't produced as much force to actually get to that highest momentum yet. So Usain Bolt obviously has the highest momentum, he has the highest mass, so he's moving that force to therefore get the highest momentum. And then myself and Amber Annings are closer because I have a higher mass, as I've said before, but I'm not going as quickly, so I'll have just a bit less momentum. Then for the 50 to 100 meters, which is the 2 to 3 at the bottom of the distance, is where every single athlete reaches their highest, their peak velocity in the race. And it's when each athlete is at their fastest. Then moving on to the 100 to 150 meters, which is the next section on, where all three start to decelerate. They moving down from their peak velocity. Usain Bolt has the least amount of slope on his line, so he decelerated the least amount. He's carrying on with still a high velocity, but not his highest. Amber Annings actually decelerates the most, going down, and then it's me decelerating not as much. But then in the last 50 meters, Usain Bolt is still a gradually decrease in velocity, but then Amber Annings then increases again as a final little sprint at the end, getting up higher, closer towards her peak velocity, and then I'm still decelerating a little bit down towards the end. And then the overall evaluation of the sprint is that, so the strengths for Usain Bolt are that he gets really fast really quickly. He goes up with his acceleration and he accelerates even more up to his peak velocity. But then a weakness is that he slightly drops off a little bit. If he can maintain that peak velocity over a larger period of time, then it means he'll go quicker than he did. And for Amber Annings as well, if she doesn't, it's the same for every athlete at the start. They do very well to get up that acceleration, but then it's in that 150 to 200 meters. No, sorry, 100 to 150 meters per hour when she actually decelerates quite a lot. If she can try and maintain a higher speed and have a line more like Usain Bolt's, then it means that she will go much quicker. And then for me, it would probably be to try and again maintain closer to the peak velocity for a lot longer amount of time to therefore make me go have a quicker time. But main things that I could do for my performance would mainly be components of fitness, my muscular endurance, trying to get that a little bit higher so I can then maintain at that last end of it to try and keep myself going as fast as possible. Also, I probably need to train on my technique from the start, as I'm not trained in sprinting or track events. It would be helpful for me to actually um, train how to properly run with the best technique that I can and start, and then also know the tactics of how I should try and get my race to be, and I would want it to be just a little bit faster at the end there, and that should shave off some time to improve my own performance. Also, then trying to improve my large maximal movement at the start to get out the blocks and accelerate faster and accelerate more so I can then get out and be quicker. And then this is my bibliography.